use the marker. And we have to erase this.
Yeah.
Try erase this too.
No, we'll keep the conditions there.
Okay.
Okay, so suppose we're given this function, f of x equals 2x squared minus 3x plus 1. The directions say to satisfy that this function meets the two conditions of the mean value theorem, and then to use what the mean value theorem actually is to find such number c that actually fits into the equation. So we know that we have a polynomial here. We know that all polynomials are continuous and they are differentiable. So this polynomial here is continuous on the closed interval. Oh, I'm sorry, I forgot to give the interval. Let's say we have interval a, b. Oh, I'm sorry. 0, 2. That's the given interval. So polynomial is continuous on this interval, and it is also differentiable from 0 to 2, not including 0 and 2. So that satisfies the two conditions. Now we can move on and actually solve this problem. Let me move this a little this way. We have 0, 2. So we know that we are going to need the derivative of the actual equation. So let's go ahead and find that. So we have f prime of c equal to find the derivative, we multiply exponent by coefficient and subtract 1 from the exponent. We have 4x, just to the 1, minus 3. So now we need our f of b and our f of a, because we have here our a and we have our b. So finding our f of b, we just take 2 and plug it into the original equation, which we get f of 2 is equal to 2 times 2 squared minus 3 times 2 plus 1. That gives f of 2 equal to 2 squared is 4, 4 times 2 is 8, minus 6 plus 1, that gives us 3. So we know our f of 2 is 3. To find our f of a, we just take our 0, plug it into the original function, which gives us f of 0 is equal to 0 squared is 0, 2 times 0 is 0, minus 3 times 0, right here plus 1, that just gives us 1. So I'm going to write, let me just erase this part. Keep in mind, our f of b is 3, f of a is 1. So we have f of b is 3, and f of a is 1. So now we can use the mean value theorem equation and plug everything in. We have our derivative, we have f of b, f of a, and our b and a is given to us in the interval. So let's go ahead and solve for c. We take our derivative, 4c minus 3, and let it equal to, actually, it might get cut off, so. Let me just erase this, and so we have it kind of memorized. We have our derivative, which was 4c minus 3. We make it equal to f of b, which was 3. F of a was 0. B is 2. F of b was 1. F of a was 1. And then our a is 0. So we get 2 over 2, which is 1. So we have our derivative equal to the average velocity. Now we can solve for our c. We have 4c minus 3 is equal to 1. We add 3 to both sides. We get 4, and we get c equals 1. So now we've solved the problem. We've come up with c equals 1, which is what the problem asked us to find. But what does that actually mean?
The meaning of this is that we picked our c in the interval between a and b, right? So as we see, our c is 1. It is indeed between 0 and 2. And this point, c, right there, our derivative is the same as the average slope of a and b. We can see that right here, that we get the same. So let's do another example now. So let's let's do something like f of x equals to square root of x in the interval of 0 and 4. So if we want to graph it, how would this graph look like? We have an x line and we have our y line. So let's say 1, 2, 3, 4. 1, 2, 3, 4. And we know that our square root dish looks somehow like this. Now we have to meet the conditions. Is our function continuous in our interval, which is 0 and 4? So here's 0, and here's 4. And as we can see, yes, it is. It is continuous. Second condition, is it differentiable? If we would pick any point between 0 and 4, we could take the derivative of it. So yes, also. So the conditions that are met. Now let's find the point which we would, let's find the point in between those two numbers, 0 and 4, where the derivative would be the same as the average slope between these 2 points. So our first goal is, what is the average slope between this point and this point? So we need to know what is our f of 0, and we need to know what is our f of 4. So if we plug in 0 into our f of x, we get 0 as an end result. If we plug in our 4 into our x, we should get 2. So let's write it down in this way. So we say our f of b, which is our f of 4, which is 2, subtracted by f of a, which is f of 0, which is 0, all over b minus a. Our b is this, our a is this, so it's 4 minus 0. What do we get? 1/2. So we have this part now, but we still need our derivative. So let's take the derivative. I'm going to write the 1/2 right here, so we can remember this is our m. And keep in mind that this is the average slope. So let me erase this part. So what is the derivative of our f of x? So let's rewrite this first. We would get f of x equals to x to the power of 1/2. So f prime of x would be 1/2 x to the power of negative 1/2. So we can rewrite this again as f prime of x equals to 1 over 2 square root of x. And if we want to write it in this equation form, we would have to write 1 over 2 square root of x, this is a square root, equals to our average slope. And remember, we found this already out, which is 1/2. So all we need to do now is to solve this equation. So let's multiply by 2. We get multiply by 2. We get a 1 here, and we get 1 over square root of x here. Right? So now let's multiply by square root of x. We get square root of x on this side. On this side, our square root of x is going to be cancelled out. We're left with 1. But since our x is in the square root, we have to square it. So this is the sign for squaring it. And we would have to write 1 squared is going to be 1 equals to x. There you go. So visually again, quick. At point x, we have here 0, we have 4 here, and we have here our average slope. At